Okay, this video should cover question 5 to maybe section B. Okay, so this video is for the 3E Combined Science End of Year 2021 paper. So I will begin with question 5 here. Okay, if you want to look at question 1 to 4, please refer to my previous video. So for question 5 is mainly on light, and we are checking whether you understand Snell's law, critical angle, total internal reflection, things like that. So for 5A, I think this student has jumped into conclusion because most of the time when you see a prism, chances are total internal reflection will happen. But you really need to learn how to read the question and pay attention to the subject. So it seems that this is the weak suit about this student because, for example, if you look at her previous question when the question asked her to talk about metal, she decided to talk about water. Then now again, if you look here, what happens is that the question actually wants you to look at surface AB, which is this yellow part, and you can clearly see that the green highlighted part shows that there's a ray going in, and it is going in from air to glass. So when you are going in from a lower index medium like air into a higher medium higher index medium like glass, TIR cannot happen. It simply cannot happen. And you can see that actually it doesn't reflect back into the air. In fact, it goes into the glass. So down here you can see that this is just a very simple phenomenon called refraction. So unfortunately, the student is too focused and become too mechanical in her thinking. So she thinks that, oh, okay, when I see a prism, maybe it's TIR, things like that. So it is not uncommon, but well, at least this paper in set 3 highlighted all these shortcomings, so you can actually have spend some time to overcome this weakness. The most important thing is that you learn about what you are lagging in and you do something about it so that you can become better. So in the second question, you are asked to explain why the light bend in such a manner at surface AB. So you can see that the light, if you don't bend it, the red line represent the original path, and you can see that the light actually bend towards the normal, right? And you know that the fact that it bends towards the normal, it means that there must be a change in speed. But in this case, because you are asked to explain, you shouldn't be telling me that, oh, the speed is different. That is not good enough for combined science. You need to tell me whether the light in the glass speed up or slow down. Okay, so in this case, first you must give me the first level of explanation that the light is entering from optically less dense, or even better, you can tell me that from a medium of lower refractive index. I prefer to talk about refractive index, yeah, because chances are sometimes you may forget to put in this very important keyword. Okay, so light travel from a lower refractive index medium to a, maybe in this case you can phrase it as a higher refractive index medium, right? After you do so, it is very important for you to give me the second level of explanation, which is to tell me, so what is this thing about refractive index? How does it cause refraction to happen? So basically, refraction is when the speed of light changes. And when you talk about speed of light changes, it will cause a directional change. So therefore, in this case, you must tell me that, oh, because it's entering from a low index to a high index, and so therefore the speed of glass will decrease, right, after it enters into the glass. Then you also must tell me that it bends closer to the normal. Okay, so in this case, if you mention to me that you are aware that it is moving from low index to a high index, you get 1 mark. In order to get the second mark, you should be commenting on how the speed change. You need to tell me whether the speed increase or decrease. The word different will not give you any mark. And of course, you should describe to me that it bends towards the normal. Okay, for part 3, we are testing whether you know how to use Snell's law. So in this case, as you can see, I picked her because she really give me A tier kind of presentation. Okay, and it is very rare to see that student present it this beautifully. So I would say that, as you can see, her language, she can work on it, but she already have a strength that many of you doesn't have, which is to present things in a very neat manner. But in this case, she made one mistake, and this is the angle that she substitute in. So in this case, you can see that down here, she have showed that the refractive index on the left side is 1. So it tells me, the marker, that she has picked this side as the air side. So it means that this angle that she is picking, theta 1, should be this angle, because I said many times, the angle that you pick is not just any angle, but the angle that the light ray make with the normal. So unfortunately, even though I warned her many times, she still make this mistake. Okay, we plant it there just to see who have forgotten. Okay, so the angle that you should sub in here should be 90 minus 51.3. Down here over, if you look at the second line, very nice. This is the glass side. So this is the glass side, and so the refractive index of glass is 1.6. And of course, if you want to find the angle in the glass side, this will be the angle X. So if you try to solve this angle, and you will be able to find what is X. Okay, so in your correction, you are expected, okay, if you got this wrong, to show me the full working and give me the right answer. So very good. Here she noticed that unfortunately it is not 2dp, it is 2sf. Okay, for your theory paper, everything is 2sf, including decimal point. Okay. Okay, for part B, we are trying to check whether you are aware what is critical angle and how does TIR occur. So here you can see that for this particular prism Q, the critical angle is already given. Okay, so we only leave you with prism B. You need to go and calculate its critical angle yourself. So how to calculate critical angle? Unfortunately, in this case, she used the wrong value again. So how do you do that? So critical angle happens when you have a light ray from the glass. You are trying to go over to a lower index medium, and at critical angle, it will this will occur. The light ray will just go along the boundary, and we call this angle of incident critical angle. So if you look at this, how you should approach this with your Snell's law is, glass side, you know that n is 1.6, and this particular angle that you are looking for is the angle C, as in here. And for air, refractive index of air is 1, and you can see that the angle made in the air side with the normal is 90 degrees. So here you can substitute 90 degrees. So you can see that in this expression, you only now have one unknown, and you can actually find what is the refractive, what is the critical angle of the glass in 2SF. So if you got it wrong, please do your correction over here. Now, if you find that this is too much for your brain and you would like a more easier manner to find, I can offer you formulas. So to find the critical angle, you can use this formula. So how to use this? So in this case, the C represents the critical angle itself, and lower is representing the refractive index of the lower medium. In this case is air, so I will have 1 over here. Higher end, it means that I want the medium of the medium with the higher refractive index, which is in this case our prism P. So you will get the equation like that, and you can actually solve for the critical angle pretty fast. So this particular equation, you can use it for all cases to find the critical angle. Okay, so again, like I said, this student is good at mathematics presentation and calculation, but she is weak in terms of applying the concept. So down here, you are asked to explain what happened to the light ray in each prism, meaning that the question is asking you, okay, now I have in prism P, I have a light ray that hits the boundary. Can you please tell me what is going to happen? Now, whenever you see a situation like this, whereby the light is traveling from a high index medium to a low index medium, you must check for TIR. So what do you mean by check for TIR? Meaning that you need to take this. This is the angle of incident, right? And you need to check that the critical angle of your prism P. Now, if this critical angle is something like, for example, like 30, then you need to make a deduction that, oh, now my angle I is bigger than this critical angle of prism P. So this critical angle is like a property of prism P. So if the critical angle is larger than that, then the special phenomenon of total internal reflection will happen. So in this case, if you have calculated the critical angle correctly, you should be able to tell that the incident angle 42 is actually larger than the critical angle, and as a result, right, TIR will happen. So total internal reflection will happen, and when you answer this, you have described what happened, but you still need to explain. So you need to explain because the angle of incident is actually larger than the critical angle of prism P. So critical angle is like a property of the prism P. Is like what is the passing mark of a test paper. So for example, if now I tell you that, oh, okay, I have a test paper, and this test paper is full mark is 120 mark, right? Then I ask you, how do you do for your test and why? And you tell me that, oh, okay, my score is 70. What does this mean? Oh, it means that my score is more than half of the test paper, therefore I pass, right? That's what you did, right? So therefore, when you want to check what happened to the light ray, you need to ask yourself two things. What is the critical angle of the prism? Oh, it is 30, for example. So what is the incident angle that we are talking about? Oh, it is 42. Oh, incident angle now is larger than the critical angle. You can't go out. Total internal reflection happens. You trap in prism. That's what happened, right? Now, if you look at your part 2 of the question, prism Q, basically they are asking you about the same thing, right? What happened, and please explain. So down here you can see that, oh, now I incident the ray at 42, but my prism Q is made of a different material, therefore the critical angle is 45.6. So now which is bigger, 42 or 45.6? So here you see that, oh, my incident angle is less than the critical angle. So therefore, TIR will not happen, right? So what will happen? Well, just a normal refraction will happen. It will bend away from the normal, right? So down here, what you need to do? Well, what will happen is that the light will refract, and you must tell me that how it refract. It will refract away from the normal. Why? Oh, okay, there are two why. Number one is the angle of incident is less than the critical angle of prism Q. Well, the other reason, so this first reason, right, angle I less than angle critical angle, it explains why it refract. And you will require a second explanation to explain why is it that it goes away from the normal. Oh, that is because air has a lower refractive index than Q, right? That's why it refract away, what? Correct or not? So that is how you tackle this kind of question, describe and explain. Yeah. Okay, let's look at question 6. It is also a light, but we are testing you on a different part of the chapter, which is your ray diagram about lenses. So in this case, most of the things are being drawn for you. You can see that the object is drawn for you, the image is drawn for you, even the lens is drawn for you. So when this happens, actually you do very little things. So whenever you have a lens, then of course cut the optical center, just go straight all the way. Then the other ray will be this horizontal ray, and once you draw the horizontal ray, you should know that, oh, it will bend towards the image, because that's where you should be going. You do not know the focal point yet, so you only see that there is this image over here, right? So without knowing this focal point, you have to draw this ray this way. So when you do that, you will find that it cuts the principal axis, and this would be your focal point. And then after that, add in all the arrows. Okay, if you do not have the arrows, you will be penalized. So in this case, by reading the graph properly, you should be able to get the length of the lens. And actually down here, you should be giving me 2SF. But in this case, for this part, we do not penalize you on the 2SF rule. Now for part C, you are asked to explain, to state what is the image property. So in this case, they already tell you that it is inverted, and you must give me two others. So in this case, we only accept real and diminished. You all are lucky because we decided to accept smaller as well. But in set 4, we will not be so kind. So we are only looking at keywords. Diminish is something that you should know and memorize. Okay, in this case, my guess is the student didn't remember and she is making a guess. So what to do if you cannot remember what would happen if the object is moved away? Well, one thing is very easy. Just sketch one more. So extend this a little bit, make it like here, and then you try lah, because you can see that this blue ray, right, it will just continue right? It is the same, correct or not? All you need to change is just this ray, right? So aim at the center and draw, right? And then after that, you would have this same ray, right, that cuts here, and you can see that now your new image forms here. So what happened to your new image if your object is being moved further away from the lens? Well, the new image is now getting smaller and it goes closer to the lens, right? So actually you don't really need to remember. You can just, exam smart. If you have a lot of time, what you can do is you put a star over here and say KIV. What does KIV means? Think later lah. Okay, come back and think later. So once you do that, you will find that actually the image gets smaller. You can also tell me that the image is nearer to the lens, right? Now, for part E, it is how should the image be positioned so that you have an image that is upright and virtual. So for this particular thing, you need to refer to your old worksheet. I do not have, let me see if I have it. I do not have it. Let me see. If you are hearing some scratchy sound, wait, where do I put it? I have it, yeah. So although it is in my 3E folder, this worksheet is also given to the 3NE and some of the combined science student. So here you can see that in this particular worksheet, I think it's called worksheet 12.3, you can see this diagram, and you can see that in order to make what they want to make, oh, I forgot, what is my question? Let's check. What I want to make is oh my god, Did I go to the wrong place? Yep. I want to have an image that is upright and virtual. So I want upright and virtual, U and V. U and V, upright and virtual. So to make an object that is upright and virtual, okay, I need to place my object at F, or I can place it in less than 1F, right? So in this case, if you remember this, then you will be able to do this very easily, right? Where should it be positioned? Well, my object should be positioned at one focal length. In this case, one focal length will be 6 cm. So you can either tell me that at one focal length, 6 cm, or less than one focal length away from the lens. Okay, so for part E, unfortunately, is either you have studied it or you have not. In fact, I strongly advise you to actually memorize this table, because in MCQ, a lot of questions revolve around image property. So if you have forgotten how to read this, basically it tells you that, oh, if now I put an image here in this region. So what is this green region? This region is within one focal length away from the lens. So if you put an object over here in this green region, I would know that you are going to get an enlarged, virtual, and upright object. So this is how you use this diagram. And what will happen if you put it right at F, or then you will have enlarged, virtual, or upright. What will happen if you put it like in the orange region? How far is the orange region? Oh, it is 2 focal length away. So if one focal length is 6, then maybe here would be, I would say 16 cm, let's say. Yeah, so that's how you use this diagram. And if you place it like here, 2F away, what will you get? What kind of image will you get? Oh, you will get diminished, real, and inverted. So that's how you use this diagram in your worksheet. Okay, go and look for it.